Hi students, welcome. In this video we are going to understand center of gravity. Here we will see what is center of gravity and center of gravity of some of the geometric shapes. So here see the point through which the whole mass of the body acts irrespective of the position of the body is known as center of gravity. Suppose this is the body and the whole mass of the body acts from the this point, as you can see here, with irrespective of the position of the body. Okay, so here this point is known as center of gravity and it is briefly written as c dot g dot. Okay, in further slides, we will see the more details about the center of gravity of some of the geometric shapes. So further see here, it is briefly written as CG. Okay, the plane geometric figures like rectangle, triangle, circle, etc. have only areas but no mass. Okay, we will see these geometric figures in later slides. Okay, so see, the center of area of such figures is known as centroid or center of gravity of the area of the body. Okay, it is also known as centroid. Okay, the center of area of such figures means the figures which have only areas but no mass. Okay, such figures have we also called as centroid or center of gravity of the area of the body. Okay, so further, every body has only one center of gravity, one and only one center of gravity. Okay, so further see, suppose this is a rectangle, this is applicable, this diagram is applicable for the rectangle and parallelogram. Okay, both has the same center of gravity. Okay, so we are considering here rectangle. As you can see here, when we join the diagonals of the rectangle, we will get a point. This point is called as center of gravity of the rectangle or parallelogram. Okay, so here, as you can see here, this is the length of the rectangle. So L by 2 is the distance of the this center of gravity here from for this figure, this for this face of the rectangle. So here this is the breadth of the rectangle, and so here the center of gravity at b by 2. So we got the location of the center of gravity for rectangle or parallelogram is at L by 2 and b by 2. Okay, so see here, the center of gravity of a rectangle or parallelogram lies at a point where its diagonals intersect. As you can see here, diagonals intersect at half the half of the length and half of the width, as you can see here at this point, and it is denoted as G here. So further, this is a triangle. So in case of triangle, the as you can see here, this is the median, the line which joins the vertex and opposite and the midi, midpoint of the opposite side is called as median. Okay, this is the median, this is the vertex, and this is the opposite side and it has the midpoint here, so this line is called as median. Similarly here, this is the vertex and opposite side is this and midpoint is this, so here this is the median, and for this also, this is the vertex and opposite side is this and midpoint is this of this side, and this is called the median. All the three medians meet at a single point. This point is known as center of gravity of the triangle. Okay, as and from the base it will has the height, that is the height of the center of gravity will be, from the base the distance of the center of gravity will be h by 3, and from the vertex the distance of the center of gravity will be 2h upon 3. This is the height of the triangle. Okay, so see here, the center of gravity of a triangle lies at a point where the three medians of the triangle intersect. As we have seen here, these three medians are intersect at this point. From base it has the distance h by 3. Okay, and from top it has a distance 2h upon 3. Okay, further here see, a median is a line joining the vertex and the middle point of the opposite side, as we have seen. Further, this is the semicircle. Okay, it has the radius r, and the center of gravity of the semicircle lies at a distance 4r upon 3 pi from the base of the semicircle. Okay, so see here, the center of gravity of a semicircle lies at a distance of 4r upon 3 pi from its base, measured along the vertical radius, along this vertical radius, as you can see here. And for circle, the center of gravity will be the center of the circle. Okay, so further see here, this is the hemisphere. Okay, for hemisphere, this is the radius, and the center of gravity of the hemisphere lies at a distance of 3r upon 8 from the base. Okay, as you can see here in vertical radius, as you can see here. Further see here, the center of gravity of the hemisphere lies at a distance of 3r upon 8 from its base, measured along the vertical radius. As you can see here, this is measured along the vertical radius. So for hemisphere, the center of gravity lies at 3r upon 8. So further here, this is the trapezium, and this is the side A of the trapezium, this is side B of the trapezium, and this is the height of the trapezium. So for trapezium, the center of gravity lies here. As you can see here, this is the point where center of gravity lies, and this center of gravity lies at a distance of h by 3 into bracket 2a plus 3 upon a plus b, bracket closed, at this distance from the base. Okay, so see, the center of gravity of a trapezium with parallel sides A and B lies at a distance of h by 3 into bracket 2a plus 3 upon a plus b, bracket closed, measured from the side B. As you can see here, this is side B. Okay, further see, this is the solid cone. Okay, here the height of the cone is h, and the center of gravity lies here, as you can see here, G, at a distance of h by 4 from the base of the solid cone. So see here, the center of gravity G of a right circular solid cone lies at a distance of h by 4 from its base, measured along the vertical axis. This is the vertical axis, and this is the base. So the center of gravity lies at h by 4. Okay, at a distance of h by 4 from the base for the solid circular cone. Okay, so students, in this video we have studied about center of gravity. Thank you students for watching this video. Like, share and comment for this video, and subscribe my channel. Thank you.